Today we're going to look at different elements and the symbols that we use to represent those elements. And you'll find all these symbols on your periodic table. Instead of writing the name of the element all the time, it saves us a lot of time, space, and energy if we just write a symbol instead of the entire name. Because some of these names are quite big, and it's just easier to write them as a symbol. So, what is an element? I guess that's probably the first thing we should talk about. And an element is just a pure substance that you can't break down. So like if we take something like water, for example, water is a pure substance. You can have pure water, but water is made of hydrogen atoms and oxygen atoms, hence H2O. So we could actually take water and break it down into hydrogen atoms and oxygen atoms. So water is not an element. However, hydrogen is an element because that's the smallest unit of hydrogen. And oxygen is an element because an atom of oxygen is the smallest unit of oxygen. So all elements are made up of an identical type of atom. So if we're talking about like a brick of gold, it is made of just gold atoms. And the smallest unit of that gold is a gold atom. So this is kind of like what Democritus was saying about things are made of atoms. He thought there was atoms of every different type of material, but now we know there's about 109 or so, according to our periodic table, elements, and then so an atom would just be the smallest unit of each of those elements. Now you can have something like table salt, for example, and table salt is a compound made of sodium atoms and chlorine atoms. And since it's made of different types of atoms, it's not an element. Salt is not an element. You will not find salt on the periodic table, but you will find sodium and you will find chlorine. So those are the atoms that make up this molecular compound. So sodium and chlorine, if we take them apart, now we have atoms of sodium, atoms of chlorine. You can't break those down any further into different things, so they are now elements. And there's pictures of what those atoms would look like, and we're going to get to what those drawings are representing later. So chemists have come up with a way of using different symbols to represent these elements, and these symbols are pretty much standard all around the world, and there's kind of a method to the madness, if you will. So we use these symbols to represent these elements, and it's just an abbreviation of the name, but there are some rules. The first thing that you will notice if you look at every element on the periodic table is that the first letter is always capital. And if you have a symbol that just has one letter, so like oxygen, it's a capital O, nitrogen is a capital N, hydrogen is a capital H. So if you have a single letter symbol, it's always a capital letter. So like carbon, carbon is a capital C. Now, if we have more than one letter, so like if you take, for example, silicon. Silicon is Si. And the reason why it's Si is because we've already used S for sulfur. So we can't use S again because then that would represent sulfur. So they are using the second letter of the name, which is I from silicon. So the second letter is always going to be a lowercase. And what that does for us, so like here's an example, is aluminum. What that does for us is it allows us to put the symbols together and know how many different elements there are. So like if I did ALO, I know that this is aluminum and that is oxygen. It's not AIO. It's A with a lowercase l and then an O. That tells me you have new elements. Or if I did like cobalt, cobalt is CO. And then if I did, let's say, nitrogen, so that would be cobalt and nitrogen. So every time you see a capital letter, you have a new element. Now, lots of times you're going to see that the symbols actually don't match the name, and that's got to do with where the element was discovered, who discovered it, maybe the original word for that substance. For an example, gold, you would think, oh, well, gold would just be G or GO, but the symbol for gold, if you look on your periodic table, it's number 79, is AU. And where does that come from? Why are we using AU? Well, the Latin name for gold was aurum, so that's where the symbol for gold came from. The symbol for silver is Ag, and again, the Latin name for silver was argentum. So they already had names for these in other alphabets, so when they were discovered, we used the letters from those original names. Sometimes it's based on where it was discovered or like what country it was and what language they speak. So for example, tungsten, the English word for tungsten is tungsten, But the German word for tungsten is Wolfram, which is the German Wolfram. So that's where we get the W from. And in German, the W kind of sounds like a V. So it's a Wolfram is the German name for tungsten. Lead is a kind of an interesting name. It comes from way back in the Latin times, again, Roman, Greek kind of era. They actually used it for plumbing. So the name plumbing actually comes from lead, because that was what they used to make water channels and things like that. They used lead because it's a very bendable, malleable metal that they could shape. So it actually comes from the word plumbum, which was actually the Latin name for lead, and that's how we get our word plumbing and plumber. Sometimes it's actually just named after where or who they were discovered by. So scandium is named after the country it was discovered in. It was discovered in Scandinavia. Berkelium was discovered at the University of Berkeley in California. Einsteinium was named in honor of Albert Einstein. So all of these symbols have kind of different origins and different roots as to where the symbols come from, but they all have the same idea that if it's a single letter, it's always a capital. If it's two letters, it's always capital, then lowercase. And just really watch out for the L's. The capital L's, depending on the font, kind of look like an I. So if I wrote this, Cl, that is chlorine. But if I wrote Ci, that is carbon and iodine. So we've got to watch out for that one. If we're going to write an I, it will be a lowercase I, unless it's iodine, basically. So those are the element symbols, and we're going to try to get ourselves familiar with where things are on the periodic table and what are their symbols. We will never have to memorize it, but it helps you and speeds things up if we kind of have an idea of where things are, maybe what their names and symbols might be.